Hey, welcome back. Now we're at Foundations Python, data types, and structures. Let's go ahead and get started. My name is Dennis, and we're going to start learning today. Our learning objectives today include being able to identify different data structures and types using their use cases. We want to create and modify sample programs to utilize different data types. And then we want to parse through larger data sets using programmatically common libraries and other methods available to us within Python. So first and foremost, data types. What are they? Well, we saw them last time, like different integers, floats, strings, lists, and there's plenty of others. Let's explore a little bit deeper as a nice review. First and foremost, Python has text. Oops. Now, text, it's only one type in Python, thankfully, and that's just a string. So if you use anything in quotes, whether it be single quotes or double quotes, it's always going to be a string. Also, no matter what you do from an input standpoint, using the input function, you're always going to have a string as well, unless you convert it to something different. And of course, if you want to use the mathematical operations on a string, you can multiply it and get the double output of it, such as multiply by 2. The other cool things is that you can concatenate strings inside the print statements, as well as the variables themselves. But you can't add anything else. So if you try to use a interpretation, right, it's going to give you an error that's saying, hey, it's a string, not an integer. So which means you just need to convert it first using the int function. Now, numericals include multiple ones. Integers that you saw, which are whole numbers, floats, and then operations between the two. If you have integers and a float together using a division or multiplication, or even addition and subtraction, it will always default to the more precision one, which is float. Okay, so let's start off at the top. A equals 10, B equals 5, actually 5.0. A plus B, you have a float. Again, if you try to actually take in, user data, and let's say you want to say, I want to convert 10 to a float. Well, you can't do it directly. You'll actually have to do something different. You'll have to first create the actual string, convert it into an integer, and then convert the integer into a float. So otherwise, you'd have to enter in 10.0, and then you could get a float directly. Another use case requirement that you need to understand is that, let's say you enter a float. Well, you're going to get a float back unless you turn it back into an integer. Now here's the thing. If you turn something back to an integer, it's going to take the lower ceiling of it, so the lower floor of it. So if you're more accurate here with 6.67, you take an integer of it, it's going to round down. Okay, it's never going to round up. So keep this in mind as you're making calculations, according to what you're looking for. Now to the truth tables. We have the and truth table, the ors, exclusive ors, and nots. Right? You really aren't going to use exclusive ors here in the actual foundations portion of your course, unless you're going to get into something like binary or other encoding encryption. Mostly you will be using ands, ors, and nots, or negates is what we call it. Take a moment, pause the video, look from left to right, only going between tables. We'll do a quick explanation towards the end of this slide. Pause the video again, and we'll see you in a second. All right. Hope you took some time to look at these truth tables because this will help you understand how expressions are evaluated inside Python. So first, the and table. Oh, I'm going to go back because my pen doesn't like that. There we go. The and table. 0 plus 0 is always going to be 0, right? A false and a false always creates a false. A false and a truth, right? Well, it has to be and, so if you don't have a truth and a truth, it's always going to be false. Same thing the other way around. And so therefore, the only time a truth is going to happen is if with an and is that if both sides are always true. With the or, if any side is true, right? Any combination, it's always going to be true. And the negate is, well, negate. Not one or not the other. Let's figure out how to use this in a little bit using another example. So, if A equals 1, which is usually commonly known as true, and B equals 0, it's commonly known as false. You want to take the Boolean or the bool function and convert it into a true or a false evaluation. If I look onto my left here, the Boolean values of 1 and 0 always going to take true and false. Right? 1 is true, 0 is false. By itself, it's still an integer. And even if you convert it into a float, 1.0 and 0.0 are always going to give true and false respectively. Now let's do some logic behind it. One of my logic tables, my truth tables of ors, ands, and negates. Well, let's look at that again. A equals 1, which is true. B equals 0, which is false. A or B, right? One side is true, still true, or 1. Let's take the true, and let's figure out how to create the Boolean value. So this being the same thing right here. Is it true? Of course it is. But if I have and, where both sides have to be true, it's still going to be false. And of course, it's you to determine the true and false. True, not false. What does that look like? Take a moment, punch it into your REPL or your interactive Python and tell me what's going to happen. Okay, now that we're back, let's look at our last example right here. In an authentication system, we also often take a stored password and look at it compared to the input password. Hence why you have incorrect passwords and correct passwords. We could say, hey, let's take the length of this, which is the insecure password of 22. And if we have the length of this is an incorrect password, right? A super long password. The difference is 1 character. If my stored password is not equal to my input password, it's always a false. That's a good thing. And of course, length. But is that the length? Should I measure the length? Because foo can still come out to the outcome of ABC because the length is still the same. So a better use case is to actually use the actual string. So rather than take the length of something, we want to actually take the actual string. One side exactly equal to the other, printing the true statement from an authentication standpoint. So let's look at this again. Why is the developer mistake? Well, here's our example to the right. If I take foobar 1, 2, 3, 4, 5, 6, still false because it's not the same exact character. However, if I take the length of both, because they're the same exact length, that's true. It's a logical conditional mistake. And that's something you need to catch yourself on. Always make sure you run through your code and understand what you're creating before you actually deploy it anywhere else in production. Now, data structures. We saw some already, right? Remember, square brackets, create a list. Or you can actually say, hey, list of something, a 10, 100. Right, that's a list too. I'm gonna have a list indexes. Take a moment to take a look at this video and what do I mean by indexes? Think back to the other module and what did I do with it? How did I call a single element? All right, do you remember? All right, let's take a look. Well, we have the index here of a list. So let's erase everything. Index 0. Let's get our pen again. Index 0, right, is at the far left. You can also say -7 because if you knew the actual length of the list, you could actually go backwards. The far right right? It's 6 because it's seven actual total elements in human terms. It's actually 6 when you're counting from 0 to 6. Still 7 nuts, and it's a mixture of mutable objects here. How do you call these? Let's take a look here, right here. Our list example here is my list in brackets. We want to print each length, right? We want to print the length of list, which is 4. Is it 4? Well, yes. 1, 2, 3, 4 that you see here. If I want to iterate over it, I use a for loop. That's what the for loop says. Hey, for something, could be anything, in my object, colon, indentation, do something else. Now here's the problem here. If I still want to do the same thing, but I only want to see one exact element at a time rather than all the elements, what will I need to do? Taking it back, use a square again, right? 2 square parentheses, or 2 square brackets, and then you can actually specify the index. And then you can verify what kind of type it is by converting the type output to a string so you print it out to standard out. Here we see the same exact thing is happening for both these items right here in the outside console, as expected. Let's take a sequence of range, right? Python range of 10, which means 0 through 10. And remember, it's always a -1, because what? It excludes the ceiling, right? That's important to remember. So my range is an object here from 0 to 9, actually. How do I iterate over it? Pause the video and think about it. Think about what you saw in the previous slide. All right, what you think about it? Perhaps we need to iterate over it using a loop. In this case, a for loop. The best thing to do is use a for loop as opposed to a while loop or any other loop because, well, you know the exact range output. And in fact, the interesting part is you can actually specify an object right there in line. So instead of creating an additional variable and then printing the range as iterable and using the variable, you have to specify the range of 0 through 9, stepping of 1, and you'll get the same exact thing. Notice here that we also get the print minus something, and I'm just doing an action against the integers right here inside my list, just to showcase that you can still do calculations even with the print statement, as long as it's evaluated using the same data type or compatible data type, like float and integer together. Now I want to show you something else. Mappings, dictionaries. Dictionaries are a really important concept inside Python because they have key value pairs, or KV for short. Key value pairs, the key is on the left side and the value is assigned to it. So here we have a mapping for my great state of Texas. TX is always equal to Texas as a string. Doesn't seem incredibly difficult. Let's see it in action. Here we have a dictionary. I'm going to say my dictionary, and here are multiple key value pairs, and they're encapsulated inside the actual brackets right there. Yeah, actually, let me get that out of the way. Brackets. Okay. I have the colons in between, along with the commas until the last one. And now my whole dictionary object is saying IP address is 8888. The owner is Google. The comment is a public-facing DNS server, and I can actually set the in-use value to true because it's still online. And the number of load balance servers that I might get an IP address for back for something is 100, for instance. I can print a very specific value of the dictionary using the key, just like I would with a list. Only I specify the key name. What if I wanted the key and value, or just the value? Well, just like last time, remember? KV, iterate over it, because you already know the entire length. So, for two objects, key and value, comma value, in my dictionary dot items. You must use the dot items method. You can say if the value is Google, print the key instead. So if I know the value, give me the key instead, which is right here. And the same thing goes with this. How do I update a key value pair? Well, you can update a key value and say my dictionary update. And let's say Google DNS is no longer used. You can say it's false. And now the same exact thing goes right here. Now, these are really simple examples, and they're simple for a reason because as we go further in the course, you're going to be utilizing many JSON values which are compatible with Python key values. The other concept is queues. So if I'm first in line, as humans, I should be the first one to get served and the first one out. Last one comes in, they shouldn't be able to cut. But here's the thing. We have first in, first out, FIFO, and then last in, first out, LIFO. You don't always necessarily have to have first in, first out, or last in, first out. Something can get out of order, but as long as your computer program is actually compensating for this, and order doesn't matter, you really have something queued up. So the back of the queue is the last portion of where data comes in last. The front of the queue is where you pop something off. So if I'm pushing something to the queue, I'm pushing to the back, and I'm popping off the front, and I'm popping it to do something with my application, and I'm adding the stuff in there for my application to do. That's all a queue is, right? It's just a line. And there's two concepts. Human concept, which is first in, first out. Or in the case of memory, right? In the case of a stack, which you'll learn about buffer overflows much later in the course. Last in, first out is actually how your memory operates inside Windows. Let's take a last in, first out approach. So I have a string and I have a list. Sounds pretty okay. I have all this stuff in my list. I iterate over it. Sounds okay to me. I can even call it based on, again, on my item here. Sounds fine to me. What's so bad about this? Well, let's start getting into some interesting items. Let's say, again, this is my list of stuff to do. I want my program to process each one of these. Well, let's say I add or remove items from my list. Like I'm adding to a queue. Well, I'm going to add, I'm thirsty, so beer 30. I also want to append 30 to it, right? So it's coming in last, pinning the stuff to the back of the queue. Well, I can actually remove elements as long as I know what the element I need to remove. So I can remove an element, such as a string in there from the front. The problem is, what if I didn't know that was a string? What if it was beer 30? Remember our indexing. Okay, remember our indexing. So let's go back real quick. If I wanted something from the front and I didn't know exactly what it was, I didn't know this was hello, I could use negative length of the list, which is instead of a -1, it's a +1. Let's go back to our queue. Ignore everything else. Let's just focus on the main thing at point here. If I pop the length -1, right, off my list, I'm popping the first. I'm sorry, I'm popping the last item off my list. Popping 30 off my list at this point. Right. So now, instead of looking at the first one, I'm actually looking at the last one because I'm adding the +1, which goes right back over here. I could say the length and add a negative, right? And so if my length is 7, add a minus in front of it, making it -7, then I can get my first and pop out first in, first out instead. I'll leave that to you. Let's think about it from a lab standpoint. So take a break, come back for our demo. Hi, and welcome back. Hope you had a great break. Let's use a really integrated example of going between and comparing different data structures. Well, for this, we'll use a list, we'll use some comparison, and we're actually going to use a different module called base64. Now, if you've never seen base64, we'll show you what it looks like. Base64 is a very particular type of encoding. For this, I'm going to use CyberChef, which is online. Now, it's important to note that if you're a cybersecurity analyst or anyone else, this is online, so don't put any sensitive data in here because you're actually sending it out via HTTP post to the actual internet where you don't control. I'm going to say go to base64. Oops, to base64. This is my random string. And notice how I put into these very limited character sets. And this is usually for making it easier for applications to understand something in case they cannot handle certain characters. So we go from my ASCII to base64. Now, one of the tell signs of this is one, a limited data set of alternating characters, but one or two equal signs at the end, which acts as a padding because it must go in lengths of a particular padding. If you double encode it, it's going to look completely different, and you'd have to decode that once more and decode it again, and now you get the reverse. That's all encodings are. They're just transforming data from one type of format to another, and I encourage you to play with CyberChef in the future as we progress through. Let's clear our screen, and let's use some sample code, knowing that base64 is part of it. We talked about particularly interesting characters. Now we'll run this here. And authentication. Most of the time, you're going to have hashing. Hashing is actually, remember, length and cryptographically strong or sound, unique fingerprints for every password or any kind of standard input. We're going to create a word list saying, hey, I'm going to try these characters until we see we have an authentication that Callie is my password. For this, we go through and create an additional encoding. We encode that into base64 from the ASCII, which we saw on the CyberChef screen. And then we can actually check my own output, which is the binary. If you see this B with a apostrophe here. Of course, our tell sign of a rather short and equals is base64. Now, for the actual cracking part, or the actual authentication check part, I can take my encoding from my word list, encode those as well, and then create an if true statement found the password. So I would check the encoded value of each one in the list, see if it finally matches this. And we get Callie and Callie. Now, from a cybersecurity standpoint, these are how password crackers work. It takes values of a hash, right? And the hash from a CyberChef standpoint could look, remember, supposedly one way, but if you guess enough times and guess the right combination, it could mean different things. So we'll use MD5 hash. My Callie is my password, and if I add a 0 to it or change it, the hash changes too, but the output length does not change. That's the difference between a hash and an encoding scheme. So that's one example. Let's use another example. Remember, we talked about dictionaries too. Dictionaries are sometimes hard for students to comprehend, right? You have essentially key value pairs. For me, it doesn't seem so bad. Pause the video, look at what we're doing, and see if you can figure out what we're doing here. All right, welcome back. Did you pause the video and figure out what we're doing? I hope so. We have 1, 2, and 3 key value pairs. Notice that this is an compressed format. I could actually just put these into this format instead, which could be this. A little bit easier to read. Notice my commas were right here, except for the last one. And then I'm saying for key and value, so key and value in my dictionary items, if there is infected in the value, print the key. So why would I use this? Well, let's say we have a bad domain list. And this is particularly how it works inside web content filtering. If I go to a bad domain or a domain classified as something such as some adult site or something that you don't want to go to, rather than look up the key right here, why don't I look up the value, right? Because the key, if I rather have clean, I can only have one value for the key. So my key should be the domain name rather than the status, right? Like your key should always be something unique throughout the entire dictionary or the database table, hint, hint. So what's going to be happening here? Well, I'm looking for an infected site. And we only print badguy.com. So if I went to that site.com, I should be blocked based on my web content filter. Okay, let's try one more here. And we're going to utilize a string instead of lists or dictionaries. And if you're wondering why we're not going over first in, first out queues, well, you'll be doing that in your lab. That's for you to figure out. Let's take two strings here, foo and foo bar. If I want to find the full length, right, of string 2, I can search between string 2 and find if it's in if there's string 2 inside, if there's a subsearch of string 1 inside string 2. If I want to do a substring search, this is the easier way to do it instead of a full length search. If string 1 is in string 2, print foo isn't found in foo bar. And then I can also do a substring search using count. How many times is foo inside foo bar? Run. So, how many times is string 2, inside string 1? 0. Makes sense, right? How many times is string 1 in full inside string 2? 0, because foo is only half of foo bar. Substring is foo inside foo bar? Yes, it's true. And count how many times? Once. What if I saw foo bar should be 3, right? These are substring searches. Pause the video, play around, try it yourself before continuing. Okay, hopefully you had some time to play with it. Go ahead and get started on your lab. We'll see you in the next module. Thanks for watching.